back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and be welcome to the Chemical Process Engineer Diary. If you want to know what are the roles and responsibilities of a chemical process engineer in real life, this is the best place where you can be. So today I have three main topics to share with you, and if you have questions during the live session, I will do my best to answer them. One of the topics is about control valve specification. I will talk to you about checklist and punch list, what are the differences between them, and also about the front-end loading tool, what is it, and how is the steps of a project or something like that. So to start with the first subject, and it is related to what I'm doing currently. Yesterday, I worked at late at night, around 9 p.m., 10 p.m. to issue a control valve specification for quotation, and I did this way because currently my working load has increased, and to be able to attend to the schedule of the project, I need to work more hours during the day. And currently I am at the home office, so it's not so a big issue because I don't need to take transportation. I don't need to walk at late at night at the town. So it's easier. People think that working at home or doing homework, you will work less, but it is totally untrue, because in fact you work more. I start my day earlier and I finish my day later. So talking about control valve specification, I took some prints about my screen here in the computer. I will let these screens available in my Telegram channel process. And what are the processes that I use to do a control valve specification? I have my process simulation in Iceman High Seas to tell me what are the properties of the fluids that I need to install the control valve. So I have a natural gas, and a natural gas is a mix of hydrocarbons. And to let my life easier about the properties of this fluid, I use the Iceman High Seas to calculate the properties and etc. And I have also a specification data sheet, a template where I need to add some information to the supplier, be able to send me a quotation. But not only that, one of the results of doing control valve sizing is the CV calculation. It is calculated by standards. You can find the standard. I'm not sure if it is ISA or other standard that has step-by-step on how to do the calculation about that, if you are talking about liquids, if you are talking about gases. So in general, I could do this calculation in the Iceman High Seas. The Iceman High Seas would give me the CV calculated for a specific condition, but that is not enough for me to do this kind of work. Why? First thing, when we are doing a control valve specification, normally we inform three kinds of conditions to the supplier. The operation conditions, that is the design point that we expect to operate the valve. We inform the maximum condition, that is for any reasons, or for a safety margin, or because eventually your process can operate at a higher capacity. And we have also the minimal conditions, or the conditions that complies or that fits to the turn down of the plant, of the process. So turn down means that if I tell you that I have 50% turn down in my process, it means that I can run my process at the 50% of the capacity. So if I am producing 100,000 tons per hour. My turning down conditions is 50%, so I can run the plant with 100,000 of production. So this is the meaning of turn down conditions, okay? And so I need to add these three conditions to the supplier or to the vendor or for me to be able to select the best control valve for my process. And instead of only adding the process conditions to the control valve specification, what I do is use the software from the suppliers to evaluate, do a pre-selection to evaluate if with those conditions it's possible to get a control valve for that case. For instance, in this case, I having 60,000 normal cubic meters per day as a maximum condition. I have 50,000 normal cubic meters per day of operating conditions and 35,000 normal cubic per day of minimal conditions. Depending on the range of the flow that you have and depending on the differential pressure that you need in your control valve, you will not be able to get that with only one valve operating. So when I use the supplier, the vendor software, and here in my machine I have the Samsung software selection and also the Fisher heater, Fisher Emerson valve selector. So I can evaluate what are the sizing of the valve, if it will be a 3 inches or if it will be a 4 inches control valve. I can evaluate the CV available, and I already see the curve of the performance. It is very, very important when you are doing the sizing and selection of a control valve to evaluate what are the curve of performance, because depending on the type of the valve, for instance, a globe valve, you don't want that at your maximum condition, the valve is 100% open. It should be around 80% of opening. And talking about the lower limits, you don't want that at the minimum conditions, you are at 5% opening of your control valve. It is around 30 to 20, depending on the supplier and etc. So that's why I use the supplier's software. So if you want to take a look about the sprints, you can go to my Telegram channel in process after this live session, okay? So this is the first topic that I have to share with you. If you have questions, guys, let me know in the chat. As I always like to ask you, tell me where are you from. I am a chemical process engineer working with plant design in Brazil. I am Brazilian, so sorry for my English, okay? The second topic is about checklist versus punch list. I learned about this in my early stages of my career when I was doing a commissioning for a polypropylene plant. So in that period, I didn't know too much about chemical process engineering, plant design. I was learning, and one of the senior engineers that was working with us in this project teach us what was the differences between checklist and punch list. And it is very, very simple, but it is very, very important at the same way. The first, let's talk about the checklist. What is a checklist? Checklist is a form that has the procedures and procedures or orientations or guidelines that you must follow before doing an activity or before completing an activity. For instance, if I need to do a process simulation in the Aspen High Seas, if I have a checklist, it would be something like you need to select the components. After that, you need to select the fluid package, and you need to enter the simulation environment. So every time that I I will proceed with my process simulation, I do a check in the conditions that I already had performed, what I already have done. So this is a checklist. And checklist is very important to avoid you from forgetting something that is important in the project. I have checklists for developing pipe instrumentation diagram, so I need to verify if, depending on the step of the pipe instrumentation diagram, I need to verify if all diameters was added to the pipe instrumentation diagram. I need to verify if all the pressure rating was added to the PNID. I need to verify if all the major equipment was added to the PNID, and etc. So with the checklist, our life gets easier, and we prevent forgetting something that is very, very important to be added to our project. On the other hand, we have the punch list. The punch list is a list that is developed after the work was done. So it's very, very common during the commissioning, the startup and erection of the plant that the construction company erects, install the equipment, but it is not totally finished. For instance, the painting is missing, or the information about safety is missing, or there is no isolation, or the valve was not locked or something. So the punch list is a list that we do to register that something was not properly delivered, or was not finished, the issue was not finished. I can't operate that. I can't start my pump for running, for operations. I can start the production, but in terms of quality and design, the system was not done. And for instance, I have talked to you about the painting. My pipelines is installed. The hydrostatic test was already done. All the weldings was done, and I did the purging. I did the flushing if we are talking about liquids, and I already can add the fluid through the pipeline. But as it was not paint, I or the operations are not able to identify what are the kind of fluids based on the color. Usually in the industrial process, for each color of painting, we have specific fluids that address to that. It's very, very common that green, dark green is cooling water, for instance. And if I'm not wrong, nitrogen could be yellow, or natural gas can be yellow. So it depends from process to process, company to companies, but it is very, very common, okay, to have this kind of thing. So in terms of operations, I don't need to wait the company finish the painting to start the production. Let's suppose that the painting was missing, or the company to do the painting is late with their deliverables, and it will take only 1 week to be able to finish the paintings. I will not expand, or I will, as I said, the company will not wait for 1 week to start producing because we don't have painting. So this is a punch list. But in terms of acceptance of the project, because when we are in the project phase, it is the responsibility of the design engineering to solve all issues related to the project. But once it's starting operations, it's starting operating in producing, in theory, now it's responsibility of the operations to solve all issues that is not related to the guarantee of the process. But in many cases, what the manager will do, they will tell to engineering or to the EPC company or to the company or to the design department. I am not able to sign this term of acceptance because you didn't finish the painting. It is still pending, so I cannot accept it. The responsibility cannot be my own responsibility to solve this. So you need to solve, or you need to fix this punch list integrally, everything that is listed in this punch list, in order that I can do the acceptance of the process. So that's why it's very, very important to you as the customer understand what are the requirements of the process in terms of documentation, in terms of field installation, to you verify what the EPC company has done in the field, and say, for instance, there is some terms in English that I don't know how to say to you. But for instance, you need to have a sign of confined space. For instance, there is equipment there that, based on the safety rules of your company, you need to have the sign or the label of confined space, and it was not added to equipment. So you need to add to the punch list. And let's transfer that to our process simulation software or to our process simulation in Aspen High Seas. What I expect from I need from the Aspen High Seas, in fact, is not the process simulation in itself. What I need is the results of the process simulation. And I can have the results of the process simulation if I click in the streams that is available there. So if I click 2 times in the stream, I can go to the tab and choose properties and verify what are the mass density, what are the viscosity, and what are the molecular weights. This is some of the information that I need to add to my control valve specification, especially if I talk about gas. So, okay, you used the checklist to build your process simulation. You did your process simulation, but let's suppose that one of the requirements that I as a customer wants from you is to have the heating material balance table. And it is possible to add the heating material balance table in the Aspen High Seas using the workbook and etc. But if you do not add that, I still can get the information that I need to do my control valve specification. However, as the job or the agreement or the contract required that the workbook was informed in the process simulation, I cannot tell you that I accept this process simulation because this item is missing, although the process simulation is functional. Okay, so this is the point that I hope that you understand from this subject. Okay, so the punch list is very, very important when you are the customer, because you will list everything that is missing, and it is why it's very, very important. Although you don't work with plan design, you understand what are the documents that must be issued, what are the documents that you must have to do the operations of the plant, and what are the fields installation that must be, what complies with the requirements, guidelines, and procedures of your company. Okay, guys, so this is it about the checklist and push list. And the last topic is about the front-end loads tool. I already started this activity here in the company that I work. If you don't know, I work in an energy company, we have three divisions in the company, and one of them is about producing biomethane from biogas from landfill. So it is very interesting process because I have I have different technologies to do that, and I am able as a chemical process engineer to study about them and to evaluate which one of them best fits to our case, a specific case, and I have been doing that during the last weeks and months. And we have a division for natural gas compression from onshore sites. So it's interesting also, but it's more restricted to compression and decompression. And in this, I have more. The main equipments are compressors and heat exchanger. In the biomethane, we have distillation columns, absorber, and etc. And there are another branch of the company that works with energy from biomass. So this I have a small contact at this point, but I will get more related to that. And what matters here for you is that talking about a project, we have many steps, and depending on the culture and depending the organization of your company, they can use a specific, use some kind of methodology to organize that. So one of these methodologies is the front-end loading procedure. It is from API Institute. I forgot association project institute or something like that. You can find on Google. And in general, a project are divided in conceptual design. That is the early stage of the project. We are evaluating what are the technologies and what are the best solution for, or the best road for a project. We have the basic and the detail engineering, where we deal with the documentation that must be issued to buy the equipments. We have the erection, and we have the startup and commissioning, startup and operation. So the FEL 2 or front-end load 2 refers to the step of the project where we will deal with the basic engineering. So the main reason to do that is to have the documentation needed to start the detail engineering, but it is associated with the quotation of the equipment. So in this phase, the objective is to have a documentation accurate enough to be able to do the quotation of 80% at least of the equipment needed in the project. So depending on the kind of project, the costs associated with equipment can vary for sure, but talking about a petrochemical plant or chemical plant, it can vary between 50 to 70% of the total cost of the project. So that's why it's important to do this step, and based on the quotation of the equipment, we can do an estimation of the total price of the project. And of course that we are talking about money, we are talking about schedule, we are talking about risks. And once we finish the FEL 2, the management will do a decision based on the price for the quotations, based on the project cost estimation, and based on the project schedule estimation. Is feasible to proceed with this project, yes or no? So the front-end load methodology, there are some gates associated with that. So there are the FEL1, FEL2, and FEL3. So these are gates that are associated with specific specific activities that must be done during this process, and after that we have the construction, direction, commissioning, startup, production, and etc. So in the following days, I will get deeper in the FEL2, in the FEL2. So it is when I will, in the preliminary phase, I was dealing with the process simulation to extract the heating material balance, and now I will need to get the results from this heating material balance and apply to the documentation. One of them is the specification of equipment, the major equipment, because they represent a higher cost in the project. In some cases, I will do the specification of control valves. It's not too common to do that in this stage. The control valves we get usually in the detail engineering, okay, but it all depends on the kind of project that you are dealing with, what are the objectives of the project, and if it's a revamp or a new plant, for instance. So we need to evaluate for case to case what is very, very important to be issued about the equipment, the documentation that you must issue. And any course for simulation, Todica, yes. If you are talking about my trainings, on June I will release my Aspen High Seas Applied to Plant Design course. Okay, currently it is open, it's closed for registration, but if you are interested on learn from me how to use the Aspen High Seas Applied to Plant Design, how to get the results of the Aspen High Seas and add that to engineering documentation, you will be able to join on June. So we have around 1 week or 2 weeks to let that available to you. Okay. If you want to receive news about that, you can join my Telegram channel in process, or you can join my newsletter going to my website, jeffersoncosta.com. You have these two options. So guys, in general terms, it is it. And besides that, I am involved with some small projects. As I told you, the control valve specification is for dealing with a behavior that we having in the onshore site, because when you specify a control valve, you specify that for specific conditions of the project. So for 20 bar Celsius at the inlet and the outlet 15 bar 20 bar Celsius. Sorry, 20 bar G and 15 bar G at the outlet. But as onshore, in the onshore process, what happens in the well is that with time the pressure decreases, and once the pressure decreases, the conditions for your control valve changes, and it can eventually it will not perform more as expected. So you need to evaluate or propose modifications, do upgradings, and it is what I'm doing. If you want to learn for free, you have the live sessions, and also you have my YouTube channel and other social media in my website. Okay, I don't dedicate my time for people that don't want to learn from me. Okay, so there is time to give you something for free, and I'm doing that right now. But for my students, I dedicate a lot of time for them. For instance, yesterday I was with my student up to midnight, and if you don't want to learn from me enough to expend some kind of money, you can use my YouTube channel, you can use these live sessions, you can use the blog that I have, and also the post in the LinkedIn. So all of this is available for you for free. Okay, about training on Aspen High Seas, it's only for who wants or who can pay, okay? So guys, this is it. Thanks a lot for being with me up to this point. And if you have any questions, you can send me in the social media. As I told you, you can find all links for my social media in my website, jeffersoncosta.com. There you'll find the links for my YouTube channel, my Telegram, if you want to connect with me, my Instagram, my Facebook, and where more that I have, it's all available there. And if you are interested in my Aspen High Seas training course, you can go also to my website, and there is a short description about it. And if you want to learn from me as your mentor, it will be very, very nice. If you don't want, don't worry, use the free content that is available here for you. So this is it. I hope you like it, and I'll see you soon in the next live session. Bye bye, guys.